Today's lesson, we're going to talk about the volume of spheres, but also composite solids. So first, we're going to have the formula for the volume of a sphere, and that is 4 pi r cubed over 3. So the only thing we need for a sphere is the radius. So 4 pi r to the third power, all divided by 3. So let's find the volume of the sphere. We see that the radius here is 7, so that's going to be 4 pi 7 cubed over 3. And I can put this all in my calculator. Most calculators to raise to a power other than 2 will have a caret symbol or a button that looks like this. And when we put this all in the calculator, we get a volume of 1,436.76 cubic inches. You go ahead and try this one. We have a radius of 8. Pause when you're ready to see the answer, hit play. All right, so we have r is 8, so that's 4 pi 8 cubed over 3, and we get 2,144.66 cubic meters. All right, for example 2, we have a diameter of 33. So if I cut 33 in half, I really have a radius of 16.5. So we're going to have 4 pi 16.5 cubed over 3. So that's going to be 18,816.57 cubic centimeters. Okay, so hemisphere. A hemisphere is half of a sphere. So if I cut the formula for a sphere in half, right, divide it by 2, then I can really turn that into a 2. So the volume of a hemisphere, the formula, is 2 pi r cubed over 3. Right, and that's for a hemisphere. So for this one with a radius of 5, we have 2 pi 5 cubed over 3, and that gives me a volume of 261.8 cubic kilometers. So you go ahead and try this one. Pause when you're ready to see the answer, hit play. All right, so with a radius of 10.8, we have 2 pi 10.8 cubed over 3. That's a volume of 2,638.33 cubic feet. So for example 4, Abby bought a lawn ornament in the form of a solid sphere. The glass used to make the sphere has a density of 0.09 pounds per cubic inch. If the sphere's radius is 3 inches, what is the weight of the sphere to the nearest pound? So I'm going to start by finding the volume, right? So 4 pi 3 cubed over 3, and we have a volume of 113.097. We could say 0.01, that's fine, or sorry, 0.1. If you recall, we talked about density being mass over volume, which also meant that mass was density times volume. We have the density, we have the volume, we're looking for the mass. So mass will equal 0.09 times the 113.097. So when I multiply this, I get a mass of very close to 10 pounds. So you're going to go ahead and try this one. Steve is crafting small spheres for a board game he's creating. Each sphere has a radius of 2 centimeters. The clay being used to make the spheres has a density of 2.076 grams per cubic centimeter. How much would 10 spheres way. So find the mass and multiply by 10. Pause when you're ready to see the answer, hit play. All right, so we have a volume of 33.51. If mass is density times volume, oh, I multiplied by 10 first, sorry. So I have a total volume of 335.1. And now mass is density times volume, so we do the 2.076 times the total volume of 335.1, and we get a mass of 695.67 grams. So now we're going to look at composite figures, which is really two or more figures that are combined. So in our first one, we want to identify the solids in the composite figure and then find the volume. So the top of our shape is really a hemisphere, and the bottom of our shape is a cone. So I'm going to find the volume of each of these individual things. So the hemisphere has a radius of 1. We know hemisphere is 2 pi r cubed over 3. So when I do that, I'm going to leave this as with pi, 2 pi over 3 right now. When I figure out the cone, if you recall, that's pi r squared times the height over 3. So this is really 5 pi over 3. And if I wanted to add these two together, I would get 7 pi over 3. And now that I know I have that, I'm going to convert that into my decimal, and I'm going to get a volume of 7.33 cubic meters. You could have turned each of these into decimals and then added them together, and that would work as well. Our next example has a cone on top and a cylinder on the bottom. I'm going to keep these in terms of pi again, just so I don't have to deal with decimals all that much. So the cone has a height of 4, and it's the same radius as the cylinder, so it's a radius of 6. So that's pi 6 squared times 4 over 3. And when I do that, that comes out to 48 pi. For our cylinder, we know it's pi r squared height, and that's 180 pi. So if I add these together, I get a total of 228 pi. And now in the calculator, that becomes 716.28 cubic meters. Again, could have found out what 48 pi was, could have found out what 180 pi was, and added those together straight away. All right, this picture, we have a pyramid, and we have a cube. If you want to call it a rectangular prism, you can, but all the sides are the same, so it is a cube. So the volume of a pyramid is area of base times height over 3. So the base is 6 by 6, and the height is 6. So our volume is 36 times 6 over 3, which is 72. Our cube has a base of 6 times 6 and a height of 6. And remember, rectangular prisms are base times height. So that's 36 times 6, which is 216. So our total volume is, if I add 72 and 216, so that's 288 cubic meters. You go ahead and try this one. Pause. When you're ready to see the answer, hit play. All right, so this was a hemisphere and a cylinder. We get a total volume of 5,089.38 cubic yards. All right, for example 8, a silo has dimensions shown. The top of the silo is a hemisphere. Find the volume of the silo. So the hemisphere has a diameter of 20, right? Because the whole cylinder had a diameter of 20, so that's a radius of 10. So we're going to do 2 pi 10 cubed over 3, and that gives me a total volume. I'm actually going to turn this one to a decimal right away. 2094.395. Then I have my cylinder, which also has a radius of 10, but has a height of 60. So we're going to do pi 10 squared times 60, and we actually get 18,849.556. So if I add these two values together, the silo has a volume of 20,943.94 cubic feet. You're going to try this last problem. We have a grain silo built from 2 right circular cones and a right circular cylinder. The height of the cylinder is 12 feet. The height of each cone is 7 feet. Find the volume, oh, and the radius of the cones and cylinder is 5 feet. Find the volume of the grain silo. So I'm going to scooch this down so we can see everything. So you're going to try this problem, pause, and when you're ready to see the answer, hit play. All right, so the cone's volume was 245 pi over 3, which if I doubled that, because there are 2 of the exact same cone, is 490 pi over 3, or a total of 513.13. The cylinder had a volume of 942.48, so combined we have a volume of 1,455.61 cubic feet. And that is spheres and composite figures.